We have organized today a webinar about tackling waste and hunger using data science. And it's organized by people in the name of Women in Data Science. And for those of you who are not familiar with Women in Data Science, it's a concept originating from Stanford University. And it's an initiative to promote diversity in the work field of data science and to give women a platform to share their knowledge and their experience in the field. Today we have two amazing speakers with two completely different talks about the subject. But before we start with those, I would like to give the word to my co-host Roos. She will tell you something about the program and our table guest of today.
Hi everyone, my name is Roos and I'm a data scientist working for People as well, just like Vera. I'm sitting here at the panel discussion table, which will be part of the entire program of this third webinar. The program of today looks as follows. So we have two speakers, two female speakers who will do an amazing job telling their stories about data science in tackling waste and hunger. We will start with the first speaker, then we'll come back to this table. We'll have a small discussion, we have a short break, then we go to the second speaker, again a small discussion, and that will be the end of the Women in Data Science webinar series, the full series. Just so you know, if you are interested in the previous webinars, you can watch them back on the WiDS.nl website, so wids.nl. First things first, so I have a laptop standing beside me. If you have any questions for the speakers or during the table discussion, you can ask those questions on the Hopin platform that you're currently logged into. On the right-hand side, you have a button called Slido. And at the Slido button, if you click there, you can find a button called Q&A, and that's where you can ask your questions. So I will see the questions on this laptop, so that's why it's here. It's not for distraction. We will not answer the questions that you're asking during the presentations of the speaker, but we'll do it afterwards because of time, and that will be during the panel discussion. I'm not sitting here by myself, so the discussion will be held with multiple people. It will be the keynote speaker that we'll see later, and Vera will introduce them. But besides me, I have Robey de Jong. Hi. Robey is a lead analytics way of working at Rabobank, and she's a known member of the WiDS community. Welcome, Robey.
Thank you.
So happy you're here. Can you do a small introduction of yourself so that people know who you are?
Oh yeah, of course. So within Rabobank, I'm setting up an analytics community. So I think it's essential that to stimulate, of course, among other things, knowledge sharing within the bank and also between analytics departments. Besides, it helps me to develop the analytics way of working that I'm responsible for. So analytics way of working guides analytics practitioners on solution exploration, development, and usage. And of course, if you draft something like that, you also have to think of and be responsible for the implementation and the support that comes with it. So yesterday we went live with the analytics way of working. So
congratulations!
Thanks. It's a huge milestone, and I'm very happy. But I'm also very happy in my role because it gives me the opportunity to share the knowledge I gained as an analytics translator along the years in a lot of data science projects within Rabobank, but also as a consultant in my previous role. So last year you said already known member of WiDS, yes. Indeed. So last year I spoke at the Women in Data Science event in one of the projects I'm involved in within Rabobank, and we aim to reduce the risk around lending to smallholder farmers. And you were there as well, and there were a lot of interesting speakers, and I loved listening and learning from them. So I'm very pleased to be here today again, and to be enlightened by Hezha and Sharon. So well, how do you apply data science in your daily job?
Very good introduction, I think, very elaborate. Last year, indeed, you already gave a presentation about lending to small farmers, mainly in poorer countries, right? Yeah. It was a really impactful type of model, and I think that's also what you really enjoy, like creating model, applying data science to situations where you can create a lot of impact.
Indeed.
And I think the theme of today also fits to that, so that's why you are also a perfect table guest for today.
Thank you.
So today we're going to talk about tackling waste and hunger. We have two really different speakers, which will be introduced later. And after their keynotes, we will come back to this table, and you, and well, me me as well, have the chance to ask a lot of questions to those speakers. So we'll see you later. Let's go back to Vera for our first introduction.
Well, thank you, Rose. Unfortunately, we cannot start right away because I have some boring practical information that I should share with you. Rose already mentioned that you can ask questions to the speakers. You can do this during their presentation already. However, they will not be able to see the questions themselves, but Rose will ask them later. However, there's another part that you need to do during the presentation. Our keynotes have prepared some interactive polls for you. So whenever one of the speakers asks a question, you are able to answer this question using Slido. So to the right side of the webinar screen, you have the option to click on Slido. Whenever one of our speakers asks you a question, there will be a poll and you can answer using Slido. Well, that was it for the boring stuff. Now I would like to invite our first speaker, Sharon, to join me on the stage. Oh, welcome, Sharon.
Hi, nice to be here.
Sharon is here with me, and she's a data scientist at Picnic. I think we've all heard of Picnic, especially in the last year. A lot of people have ordered a lot of food online during the corona lockdowns. However, Sharon is not just spending all her time there programming and making models. She also loves to share her knowledge. For example, she has been a lecturer and she's still a fitness instructor, so broad range of interest. Today, she's going to tell us about balancing availability and waste at Picnic. So Sharon, good luck and have a lot of fun.
Thank you. Food waste is still a big topic in the European Union. In 2016, the EU published their report on how much food waste or how much food we are wasting every year. And the numbers were shocking. It is estimated that around 20% of the total food produced in Europe gets wasted. So let me repeat that. 20% of the total food produced in Europe is wasted. That amounts to around 80 billion kilograms of food every year. And it's important to remember that food wasted is not only food that is thrown away. Food wasted also wastes land, energy, water, CO2, and everything that is used to create this food. And the total cost is over 100 million euros every year. Now, this food waste occurs in different sectors. We have food waste at production, during processing when everything is packed, in wholesale retail, for example at supermarkets, in the food service, and at the consumer. Now my question to you, we're going to already start with a Slido, with a poll. Which sector produces the most food waste? Do you think this is production, processing, wholesale retail, food service, or the consumer?
Well, Sharon, some people already found the polls, but quick reminder, click on Slido. Now the poll is visible and you can give your answer to the question.
What do you think?
Well, my first thought was processing, but then I thought that you especially ask for food waste, and I was like, I think they waste a lot of things, but not food, especially. So, yeah, then I would say the consumer. But
okay, and what does the audience think?
The audience doesn't agree with me. They they think the food service sector.
The food service. Okay. Well, it's actually the consumer.
Oh.
Yeah, so your second guess was correct.
The public has just in time also come to the conclusion. But
okay, so it's mostly at the consumer. So actually 55% of food that gets wasted is at the consumer level. Now this was a bit of a trick question because today we're going to talk about food waste at supermarkets, so in the wholesale retail section. Now why are we talking about this part of the supply chain? This supermarket is most of the time at the end of the supply chain. Large quantities of food are collected at limited physical locations. And these make it very good targets to implement food waste reduction measurements. And from all the food that gets wasted, 5% happens at wholesale and retail. Now you might think 5% doesn't sound like that much compared to the previous numbers, but I want to put it in perspective for you. So let's think about it in apples. This 5% is around 4 billion kilograms of food. Let's say we take an apple, which is around 150 grams, if we show the amount of food waste every year in apples, this would be around 26 billion apples. Now, if we would stack all these apples on top of each other, we would have around 4 million kilometers that we have to travel, which is around 66 times around the world. Now, I hope you can all agree with me that food waste is a very big topic that we need to tackle, and that it's also important to tackle this at supermarkets. So what are the main causes that we see for food waste at supermarkets? We identify 3. The first cause is mostly damaged products. So for example, if a product or a bottle of jam gets broken or a box of eggs get broken, we cannot sell these to the customers and they get thrown away. The second problem is quality. For example, if an apple is out in the sun too much or a carton of milk is kept out of the refrigerator for too long, we have food waste because the quality is not good enough. And then the third problem, or the third cause, that's maybe the most relevant and the biggest in the industry, is expiration. So remember that at supermarkets we sell a lot of perishable products, which means products that have a short expiry date. You can think of eggs, milk, meat, and these products have to be sold quickly, otherwise they will go to waste. And then if we forecast too much demand and we cannot sell them, we have to throw them away. And here, demand forecasting comes in. So this is what we're going to focus on today. We're going to see how we can predict demand for supermarkets. We're going to dive into the data and how we can use machine learning to create more accurate demand forecasting. And we're going to look at how COVID changed customer behavior and how it showed us that we need more resilient models. But first, let me introduce you to Picnic. So hopefully many of you already know what Picnic is, but Picnic is an online supermarket, an online-only supermarket. We are in 3 countries at the moment. So we are in Netherlands, Germany, and since a week we are in France. And here we deliver groceries at your door. Our mission is to make grocery shopping fun, simple, and affordable. Now our value proposition is as follows. We are a mobile-only supermarket where you can deliver or you can shop for your groceries for the lowest prices. You can deliver your groceries on time in a 20-minute time window. And you can order up until a day ahead, and we deliver at your home, maybe even towards your kitchen. So this is our value proposition at Picnic. Now let me show you why Picnic is disrupting the supermarket industry. And for this, let's take a look at how the traditional supermarkets work. So this is an overview of how the traditional supermarkets are working, and this is how we are doing it already for more than 50 years. We have the producers, warehouses, and we have a lot of physical supermarkets, and the households go by car or by bike to the supermarkets. Now at Picnic, this works a bit differently. Here, we started from scratch, and this means that we took out all the physical supermarkets. This way, we have our warehouses where the food is stored. Our consumers can order from their house with the app, and we deliver at the door. We drive fixed routes through the streets, so we are in your street once or twice a day. And this way we can optimize everything in the supply chain, making it more efficient and very useful for machine learning applications. Now, if we zoom a bit more into how we order at Picnic, we are a just-in-time supply chain. This means that we try to order our products as late as possible to guarantee the freshest quality. Preferably, we order our products after the customer has ordered them with us, so we know the exact amount. But this is not always possible. Sometimes we need to order it up in advance, and for this we need accurate demand forecasting. Now, if we predict too little, then we have another problem. So if we predict too much, we reduce waste, but if we predict too little, we actually have a lot of unavailability. And this means that the product is out of stock and the customer cannot buy it. Now we're going to go back to a question for the audience. And this is a question to illustrate why it's so important for Picnic to balance this waste and availability. Now imagine you have a nice dinner party. You have a delicious meal you want to cook tomorrow, and you have to go to the grocery store to get 15 items. Now you're in the store, and one of the 15 items is out of stock. What do? Do you drop your basket and go to another supermarket and buy nothing? Or do you still buy some products at the supermarket? So would you leave a supermarket when one product is out of stock?
Well, for now the audience agrees. They wouldn't leave the store, but...
What would you do?
Yeah, I think it would depend. I think I would just buy the items that are available. However, if I would shop online and I would still have to go to the supermarket, then
yeah,
maybe I wouldn't.
That's a very valid point. I would also just buy the rest of the products and then just buy the last product at another store.
Yes, exactly. But
I think everyone agrees with this.
Yes.
Thank you. Now this clearly shows why it's a bit different for picnics. So this is something that Vera already quickly mentioned. If you order a picnic, you order via your phone, you order at home, and you didn't make the time investment to go all the way to the store and already put things in your basket. So if you're on your phone at home and you see that the bananas you so desperately needed are not available anymore, chances are that you will stop your order and just go through the grocery store because you already know that you have to go to the supermarket. Because this big time investment is not yet made, it's very probable that we lose customers and that we lose orders. So hopefully this shows that, especially for picnic, it's important to balance waste, so not predicting too much demand, versus availability, predicting not enough demand. And this is a very tight balance, and what can really help here is machine learning to create accurate forecasts. Now today, we're gonna dive into how we can use machine learning for predicting demand at supermarkets. We're gonna look into the data. We're gonna dive into the data, and this shows you that the machine learning for article demand forecasting is actually very interesting for supermarkets compared to other e-commerce companies. Now this has all to do with the data, and for this we're going back to a question for you. So how often do you shop for groceries? So think about the last time you went grocery shopping, what was the previous time? How often do you do this? Is this daily, twice a week?
I go every day, I think. I always forget everything, so I have to go back. Sometimes twice a day, but...
Yeah, I'm the same way. I usually go 2 times a week if I don't forget anything. But it's quite a recurring pattern, right?
Yes, the audience once a week is prevailing now, but...
Okay. Once a week. So definitely not someone that goes every month. So it's usually more often, right?
Yes, yes.
Okay, so once a week is the general opinion.
Yes.
Once a week or more often.
Thank you.
Now, what does this show? This shows that there are a lot of frequent orders. And at Picnic, we actually see that customers order around 3.5 times a month, which is almost every week. Now, why is this so nice? And especially as a data scientist, for the data has a lot of frequent reoccurring patterns. If you compare it to maybe bol.com or Amazon where you buy books, you might not do this every week, but you still need your groceries every week. So what we see is that in our data, we see a lot of frequent orders, very reoccurring patterns. Now, if you think at what is in your grocery basket, usually we see a lot of similar products. So most of the time, 80% of what is in your grocery basket is the same as something you bought before. Now think about what you are buying. Usually breakfast and lunch is quite similar, or your favorite snack. So we see frequent orders with very similar products. Now the third thing we see in our data is that it has a lot of large baskets. Usually when you do grocery shopping, you have 20, 30, maybe 40 products in your basket. Well, if you compare it to normal e-commerce companies, maybe it's 2, 3, or a handful. And so what you see here is that we actually have a very nice data set with a lot of patterns that we can pick up on about grocery shopping. Now, how can we, Now, what you would expect is to see something like this. if we take a look at the article demand at a supermarket. Maybe tomorrow we need to buy 50 bananas, in a few days there's 40, several days there's 60, because we have this very stable, reoccurring pattern of doing groceries, right? Now in reality, we actually see something more like this. So we see on day 1 maybe 50 bananas, in a few weeks thousands, and then in a month 10,000. So this is a very different line than what we would have expected. And it has everything to do with that Picnic is still a scale-up. We are growing immensely, and we are expanding our customer base. So what you see, if you zoom into deliveries, you actually see a similar pattern. So the number of deliveries or the number of groceries is increasing rapidly. Now, how do we get back to that stable pattern that we wanted to predict for? We can actually use the demand, the actual demand that we see, and decompose it into 2 different signals. The first signal is how many products are in the basket, so how many bananas do I expect to see in a delivery, times the number of deliveries to get the final actual demand of bananas. Now we decompose these 2 signals, and for article demand forecasting, we can zoom in onto predicting the article per delivery rate. So for the delivery forecast, we can give this to a whole different system, a whole different machine learning-based approach, and we are going to focus on article per delivery rate. So how many bananas are there in every delivery? Now, how can we create features for this? We actually identify 4 different types of features. The first one are the past targets. So this means how many bananas people have bought yesterday, a week ago, 1 month ago. And these are very strong signals to predict how many bananas people are going to buy tomorrow. So these are our past targets. The other type of feature are static features. These are features that don't change over time, but are constant, are static. For example, information about the product. You can imagine that the repetitiveness of how often you buy shampoo can be very different than how often you buy bananas. So these are very static signals that can give a good signal to predicting the actual demand. And then we have 2 other types of features. We have, or one type of feature with 2 different subtypes. We have the dynamic features, which change over time. So every time step we change, but they are known. A very good example here is the day of the week or the month of the year. So even though this changes at every time step, there's a fixed pattern, so we already know what is coming. And these features can give a very strong signal. For example, you might think that snacks would be bought more often in the weekend than on a Monday morning. And these things can give strong signals to our models. And then the last, but not least feature, is the dynamic unknowns. And these are features that change over time, but we don't really know in advance. And a good example here is the weather. So we know the weather today. We might know some forecasts of the next days, but we don't know the actual weather it's going to be. And a great example here is that if you see that the sun is coming out, people will buy more barbecue products or more ice cream. So these 4 different types of features can have very strong signals to predict our final article delivery rate, the ADR. Now let's dive into the model. The model we're using here, and that can very well use all these different features, is the gradient boosting regression tree. Due to its architecture, it's fast, it works very well for these time series forecasts, so for these forecasts on demand, and it is very flexible. And it can use all these different types of features next to each other. Something that is important to keep in mind is that the gradient boosting regression trees can only predict for 1 target at the same time. For example, predicting only for the demand that we expect to see tomorrow. Now at Picnic, we need to buy our products a day in advance from our suppliers, but not only a day in advance. Several days before, we need to make orders at our suppliers. And at these time steps, we also need a model that can predict for the delivery date. Now this means that we actually have multiple models working together to create separate predictions, because we have different targets, so 1 day ahead, 7 days ahead, n days ahead, and all of these models predict the target. Now we have our models. Now it's important to evaluate how good they actually are. And for this, it's very important to talk with the business. It turns out that we are, in this case, not really interested in the absolute error we have. So the exact difference in predicted demand and actual demand. For example, if we are 0.1, we have a difference of 0.1. For a product that has a very low ADR, this difference can be 100% or 200%. While if it's an ADR that's much higher in general, this difference is actually quite small. So in the end, we talked with the business and we went for the WAPE. So it's a weighted average percentage error. And what this does, it looks at the percentage of difference compared to the actual value, and it also weights according to how much demand there actually was for that product. If you think about the products that are in a supermarket, some products are bought really a lot. For example, milk, cucumbers, cucumbers I already said. Milk, cucumbers, bananas, of course. But there are also products that are not bought that much. And for us, it's more important to correctly forecast the demand of the products that are bought a lot, because they are bought in big quantities. And this is what the WAPE does. So the weighted average percentage error. Now we had this model, it was running in production for a few months, and then we had a black swan event. So a black swan event is an unpredictable event that has a large impact that you could not really have anticipated. Now this was a year ago. I think everyone knows that I'm talking about COVID. So COVID impacted a lot of people, and it also impacted how we do groceries. Online food exploded. People were dying to order from their phones instead of going to the physical supermarkets. Either they didn't find it safe, or they had family members that were in a risk category. But online food exploded, online delivery exploded. What we saw was an unprecedented shift of grocery demand towards online. So what you see in this graph here is how often people Googled online groceries, or the Dutch online boodschap. And in the beginning of the year, so this is all in 2020, in the beginning of the year, in January to March, you saw a very stable trend line. And then suddenly, it spiked. So the shift towards grocery demand on online was huge. This was so much that it was difficult to fill the capacity we needed to get all this demand out. What was happening for our model was that we actually were seeing constrained demand. We didn't have as much capacity to fill the actual demand, which meant we had to cut off order times. Now this data gets fed into your model again, and this model has to work with this unconstrained demand. Now we not only saw a shift in how much people wanted to order, we also saw a shift in when people wanted to order. So in February 2020, the pattern of when people were ordering was a bit like this. Most of the people ordered 1 day ahead, maybe 2 days ahead, up until 7, but then it dropped down. When we look at April 2020, we see a very different pattern. Now most of the people were actually ordering 4 days in advance, or 7. So the models before that were extrapolating from seeing the demand on day 3 and expecting a linear increase to day 1, were actually not working that well anymore, because that pattern was not there anymore. This also meant that different horizons became important. And as we mentioned before, we are using different models for different horizons. So different models became important. Now, after seeing a shift in how much and when people were ordering, we also saw a shift in what people were ordering. This is a plot where you see the predicted demand versus the actual demand. And you see two bit of weird spikes, these two. What is happening here is that we predict much lower than the actual demand was. This is caused by having unseen ADRs. So this is something that is happening in the gradient boosting trees, and they cannot handle seeing ADRs that were not seen during training. Now we saw suddenly these spikes or these shifts in distribution. Let's give a few examples. I think everyone can remember that everyone was stocking up on toilet paper. But this was a huge spike in demand that we didn't expect, that we have not seen before. Or people that were ordering a lot of canned food. Now, these unseen demands were very difficult for the gradient boosting regression tree because it could not extrapolate to anything that it hasn't seen before. Now, you saw that there were 3 different challenges that were highlighted due to COVID in our model. And because of this, we reevaluated our model and we decided to go for a temporal fusion transformer. This is a model that was created by Google a few years ago. We won't go into the very specific details, but I highly recommend you to read the paper. But in short, it's a self-attention deep neural network that can pick up on temporal patterns, so patterns that we see over time. It can predict for multiple horizons at the same time, and it has good interpretability. Another thing that's very interesting about this model is that previously transformer models were not so good at tackling all these different features. So we had the static, the past targets, and the dynamic features. It couldn't handle them at the same time. Now with this temporal fusion transformer, it can. So now we can leverage all these different data types and all these different features into a sequence model that can actually extrapolate much better than a gradient boosting regression tree. Something that's super nice about this is that it can also predict multiple horizons at the same time. So instead of having 1 target, we can predict for up to n targets, and it can use the information it has that it predicted for 1 day ahead, for how much it's going to predict the demand 7 days ahead. So we can use one model to predict for all these horizons. Something that's also very interesting is that we now also have confidence intervals, and this is very useful for the business. For example, we can tell the business that the model is around 60% confident of its predictions. And then the business can decide to put on a specific safety margin so we make sure that we have enough demand. So this model actually brings us a lot of advantages. We saw an improved extrapolation. We have now one model to rule them all. And we have these confidence intervals that we can share with the business, making it a much more robust and resilient model. Now, before we go to the discussion table, let's recap what we discussed today. Food waste is still a big problem in the European Union, and we have to tackle this waste together. At supermarkets, we can reduce food waste with machine learning-based forecasting. There, it's still important to keep a balance between waste and availability. And if there's one thing that the pandemic showed us, is that we need to make models more resilient to shifts in customer behavior. Thank you for your attention.
Well, thank you, Sharon. It was a really interesting talk. I've never thought about how that balance works for you, that you have to have enough, but you don't want to have too much. I never thought about it. Well, I never ordered food online until yesterday, so maybe that's why. But I would like to invite you to take your seat at the table, and good luck.
Thank you.
Hi everyone, welcome back to the discussion table. While Sharon is to be seated, I just want to remind you that you have the possibility to ask questions. If you are on the Hopin platform, you can go to the right-hand side. There's a button called Slido. In there's a button called Q&A, and that's where you can ask questions. I will get the questions on my laptop here, and at the end of the discussion table, we'll get to your questions, or I'll try to put them in the discussion that we have here. Welcome, Sharon.
Thank you.
How did it go? I think it was great.
I think it went well, yeah. Yeah, it's a very easy, understandable topic, I think, because everyone does grocery shopping.
Yeah, and it's really funny because you have a lot of examples that actually fit to a lot of people and how they experience certain things. So that you ran out of stock or something, or that you order your bananas every week. I do that at least. Let's first start with a little bit of background about the company, because people might know Picnic, but they don't know how big maybe your data science team is or how it's structured. Can you tell a little bit about that?
Yeah. At Picnic, we actually have quite a big tech team. I think we're with more than 150 people at the moment. And then the data science team is at the moment 6 people, excluding some interns. So we have 6 data scientists, and we are a centralized team that does projects for different types of teams. So we do projects for different parts of the supply chain.
Yeah, so it's like you are the core data science team, and from different departments of the business, people come to you and, you make models or you do your analytics.
Yeah, so we have projects maybe for 1 quarter or 2 quarters, and then we reevaluate whether that's the best project that has the highest priority at the time, and then we can switch between the different projects at different supply chains.
Yeah, and you mentioned that Picnic is currently available in 3 countries, right? Yeah. Netherlands, Germany, and France. Is your team also the team working for the different countries? Yeah,
so at the moment we have 1 team that is creating models for all the different countries. Sometimes it is interesting, for example, if you do a model that's more related to natural language processing, it can be nice to have someone that speaks well in French or in German. But at the moment we are creating separate models for all these countries, yeah.
And are you also the team that's maintaining models?
Yes. So we are very full stack. We have discussions with our stakeholders. We create the product planning, experimentation. Then we put it into production as well, and then we maintain it afterwards.
It's quite a busy job, I imagine.
Never a dull moment.
No, never a dull moment, definitely.
I know, Robey, from your side, you are a way of working expert. How, does that fit into your models as well? So you have a data science team that is both doing new stuff, implementations, building models, developing, but also maintaining the models that are actually there?
Yes, indeed. So it helps you from if you have an idea, that you have the conversation with the business all the way to, in maintenance as well as retention. So if you would like to replace your model, so it helps you on all these various topics.
Perfect. I think most of the people that are watching are interested in the modeling itself and in the data science. And I know Robey and me have a lot of questions written down. We have a lot of things to talk about. I don't know, do you want to start with a certain
I can have I have multiple questions. I wrote a lot of things down. Because you mentioned like you're live in 3 countries and you already showed us that you have a large assortment. So I was wondering, then you have to make a trade-off between you're going to make a scalable model or a predictive model. And how did you make your choice in this trade-off?
So especially because Picnic is still a scale-up, scalability always has to come into mind. We know that we're going to grow a lot, which means that it is important to keep your model scalable. How we approach it most of the time is we take more step changes. So we focus first on the products that are giving the most return of investment, that are the most important or the most bought, and then we first create stable models for that. We usually go for first a baseline model and then build from there. So we have, for example, the average of what people bought tomorrow, and then we build it to a gradient boosting regression tree, and now we've built it to neural networks. So we make sure that we have models that are scalable and can slowly predict more and more.
Okay, I think that's a good coverage, but then you can easily scale it, but also include other products. Yeah. And how have you determined the products? Is that something that you do with your team as well, or data analysis, or is that something that the business?
So we are working closely together with the business. So we have very strong business analysts in the operational teams, and then we work together to see which products could have the most benefit from our machine learning model. Usually we focus on, in this case, the products that were bought most often, because then there's a lot of turnover there. And then we focus on that, and then slowly we can roll it out. And if they have any great ideas of what additional things we can implement, it's always an open conversation that we can iterate on.
Yeah, I think it's nice. And I think having a lot of assortment poses also a lot of challenges.
Yeah.
There's some interesting learning.
Yeah, definitely. So if you think about the supermarket assortment, there are the products that are bought super frequently, for example, milk, and you have products that are not bought that much. A very common example is fish sauce. Fish sauce. And these patterns are very different. Also, how people are buying these products is very different. So what we noticed is when we were trying to predict for everything at the same time with the gradient boosting trees, the performance actually went down because it could not handle all these different types of signals. So at that time, we needed to create separate models for each. Now, this problem is not there with the newer model we're using, the TFT model. But it's definitely something to keep in mind that what works for the banana doesn't always work for the fish sauce.
And then you have to search for the generic components.
Yeah, definitely. And what we try to do is we experiment on different subsets so we can expand a bit and see, okay, maybe this is quite a similar product. Can we add it to the list? And then you can build from there.
I wonder, so you've been substituting the boosting model with the new model of the famous paper.
Yeah.
How did you decide that you wanted to make the transition? So when do you decide, okay, this model is really not good enough anymore, we need to move to something different?
Yeah, very, very good question. So we are always in conversation with our business analysts. We have dashboards to track the performance over time. And what you saw with the pandemic is that there was this shift in customer behavior, and our current model couldn't handle it. And so we also saw this in the dashboards. And that was the time that we decided to experiment with different models. So we had a list of also an LSTM model, the TFT model, other sequence models that we wanted to try out. There were some experiments done offline, and then we created a whole overview of which worked best. Now, we chose this one because this was the best, and it had also a lot of advantages because we only need one model instead of, for example, 7, which is really useful in maintenance. And then we are now implementing it, and then actually we're shadow testing it. So we are running it next to the old model and not doing anything with the predictions, but already storing it so we can evaluate over time. And because we can do this, we can kind of gain the trust of the business because they can see how the model would have been performing if we would have already put it in production. So this transition period really helps with that.
And do you see that this new model is then always performing better, or is it like a trade-off between one time it's one and one time it's the other?
Yeah, so we do see some trade-off. The trade-off you're also making is, okay, maybe it performs a little bit less, but we can now predict for much more at the same time. So that's the trade-off you need to make. You cannot be always the best at every other.
Sweet spot.
Yeah, exactly.
Yeah. I was wondering because you sometimes have a good or a bad forecast.
Yeah.
How do you discuss that with the business, and how are they part of your team maybe to be able to adopt a model more easily?
Yeah, so we have a lot of discussion. So we are working closely together with analysts to keep track of this performance, and we have regular check-ins to see what the performance actually is. Next to that, we also have these dashboards that the business can see how much food waste or unavailability there is, and that you can directly relate it to some of the forecasts. Yeah.
I think that is a huge advantage that you're a small team and that you can easily...
Yeah, because the company is still, it's getting bigger, but it's very easy to step to another team and ask, like, hey, how is it going? And to have a quick call with them. I think this is very nice about being a centralized data science team, that we can also see multiple parts of the business in this case.
Do you think that also helps with the explainability of the model?
Yeah.
They're involved more closely, that they understand what you're doing, and adoption will be...
Yeah, and I think, well, most people at Picnic are also super curious, so they want to know how it works. And if you're replacing a model that was run in a business, you cannot replace it with a black box and say, hey, this is great, just use it. Because it's impacting the customer so much. So there is a very strong need for explainability, interpretability. Why are we predicting less or more in the next days? What is causing it? So I think this is something we always keep in mind when we're working on our models. Yeah.
Do you see a big difference between explainability between a tree-based algorithm and the neural network that you're currently using? Because neural nets tend to be quite black box, right?
Yeah, definitely. Now, this is one of the reasons why we went for the TFT model, because it has more interpretability or explainability. So you can see more of the global, the impacts that certain features have made. And this was something that why we were more comfortable also switching to this model, because that is definitely something that is important.
Talking about features, I think you mentioned a few types of features that you look at, right? You have the static features, the known and unknown dynamic features, and I don't remember the first one.
The past targets, so how much people were buying before.
So I was wondering, seasonal patterns, they probably a lot of them come back in the known dynamic feature types, right? But for example, Easter, that was recently happened. Maybe people buy more eggs with Easter. I can imagine. How do you have that information in your model?
So part of it is also in the past target. So usually there's not one big shift within a day. It's a gradual increase. Maybe a week before Easter, you start to buy your eggs, and then more and more people are buying them. So this information is in this past targets. Now what we do at Picnic is that if there's a promotion or there's like a holiday, for example, Christmas, and there's a lot of things on sale, the demand shifts a lot. And we actually use different models. So we use promotion demand forecasting models to tackle that. So this model is just focused on the basic patterns that we see over the year. While if we expect a big shift or big change because of promotions, we can use the different model.
Oh, wow.
Yeah, but I thought if I remembered correctly, I also noticed that weather is something you take into account.
Yeah.
How does that work? Because I don't think you have that data within Picnic, so how do you have access to it?
Yeah, so we have at Picnic a centralized data engineering team that's next to the data science team, and they handle a lot of data, so they make the data very nicely structured and clean for us, which is
great.
Lucky you.
data science heaven at Picnic. Yeah, no, I'm really happy with this. And then the weather forecast, we take from an open API dark sky, and it gets pulled from there. So we have this historically as well. But then instead of us having to scrape it, we have it in a centralized warehouse.
Yeah, then you have to analyze it and see what the impact is per product.
Yeah, yeah.
I think this is a great tip for the people that are watching. The dark sky.
Yeah, dark sky.
Can you say again how?
Dark sky.
Dark sky.
It's an open API.
Make sure to Google that. I was wondering, because you mentioned that you have the models, and I think they are fit to a certain product group or really to a specific product. How do you work with new products?
Yeah, good question.
Especially with the seasonal patterns, and like, how do you know anything about that?
Yeah, this is difficult, right? Because you don't have the historic buying patterns. So for this model, we actually say, okay, we exclude products that just started because we don't really know how the demand is going to go. And then there are still some processes at the business side that know how to forecast for that. Another thing you can do here is also look at more article features. And we have a list of products that look like a new product. Then we can use the demand that we think that product is going to get for the new product. But it's always a difficult thing because you don't know, you don't have any history about the product.
Yeah. And I was wondering, because you have a small team and you're working on a lot of different topics, so I was wondering, how do you do the retraining?
Yeah, so when we create our model, we try to also have some time at the end to implement an automated retraining pipeline. Okay. So for this model, for example, we retrain every week. So there's just a machine learning pipeline that gets newer data. So it's the same model hyperparameters, but just with some newer data. And then we retrain it, and then if we see that this model performs better than the previous model, we push it to production. If it's not, then we don't push it to production.
And how does that work? Do you do that automatically, or do you have to discuss it with the business? Or
yeah, so we have the weights, so the weighted average percentage error. We can evaluate this for the older model and for the newer model on a test set. And then we decide if it's above this threshold, we can push it to production, and we check also if not, suddenly the variation is very different. So we want, of course, a model that is better on most of the products, not something that is maybe extremely good on one and then suddenly very bad on the other, averaging out into a better performance. So we check for this as well.
Yeah, and I was just wondering, when you do the retraining, maybe new outliers will be identified. How do you act upon them as a team? So
what we usually have in our data sets now is some sanity checks. So if we think that there are something strange in the data that we don't expect to see, we have some checks beforehand. But it also helps to have these strong connections with the analysts and the people that are looking at the dashboards that can immediately kind of signal like, hey, there's something weird going on. Can you take a look? Yeah.
Does that also mean that, for example, in the COVID situation, you purposely change your training data for the models?
Yeah, so I'm not 100% sure what we did for this model, but for other models, we, for example, removed some of the code. Like in the beginning, when we thought it would only last for 3 months, we just removed some of the data and saying this is unexpected behavior. This is more similar to either promotions or when you have unavailability, we just filter it out. Now we're already a year in, and this is not possible anymore. This is the customer behavior has changed also after this year. It's not gone back to how it was before. So now, because we have these features over the last few months, you do pick up on just the newest behavior that customers are having. Yeah.
I have a few questions coming in from the audience,
Ooh,
so
okay.
maybe we can go to that. Some of them are technical, some of them are also food waste related, because that was the purpose why we have this model, right? Let's start with that one. Johan is asking, when you look at food waste, what can you do to improve the length of, something shifted, to improve the length of the food chain, maybe together with Picnic?
To improve the length of the food chain.
Yeah, so how can you make, maybe, I think what he means is, how can you make products longer available, or how can you make sure that, that the food chain is a bit longer and that you have to throw away less? Yeah,
so what we are doing is really trying to order at the latest moment, so that we have the longest guarantee for freshness. Now this, of course, also shifts maybe the responsibility from us to the suppliers, right? Because we are ordering at the latest moment, but they still need to buy it up front. Something we're doing there is actually sharing the forecast that we are making for a week in advance, several weeks in advance, so that they can also buy their supplies or share their supplies more accurately. I think this is something that really helps, so that you don't have the shift of or blame of food waste from us to suppliers, but that we work together in the whole chain.
And I was wondering, when you're using a gradient boosting and you have under and over estimation, which results in waste as well and unavailability, what are other initiatives that Picnic has to reduce waste?
Yeah, definitely.
Set the forecast, but are there others?
Yeah, so next to machine learning, we are actively tracking also the food waste that is happening. So if we see that the product this week has more waste than we expected, we can also talk with the supplier about this, see whether we can maybe change the freshness guarantee a bit. Something that is very interesting as well is that when something is a product we cannot sell anymore, means that we cannot meet the freshness guarantee, which is usually like 3 days, for example, for I think lettuce or something. While if you would look at a normal supermarket, there it goes on sale on the day that it expires. But for us, we cannot use it 2 days. We cannot sell it 2 days in advance, which means we actually have a lot of good products that we can easily give to the Voedselbank. Okay. And as well, we can also use them in our own canteens. So, which was also very useful. Yeah. So we use them in our canteens, and this tackles food waste, and it also reduces costs for us, of course.
Wow. Smart. Good idea. Yeah. I have 2 more technical questions over here. First one of Sharon. She's asking, or he, I think she, when using gradient boosting method, was it necessary to convert dynamic features to static ones through, for example, aggregation, or static features to dynamic ones? So do you need to change features such that they either get dynamic or get static in order for the gradient boosting to pick up the features?
No, so this is the nice thing about gradient boosting trees, that they can handle all these different types of features. You also don't really need to do any normalization, which makes it much easier. How it's set up is that you actually just take the features that you knew over time. So you know the past demand, you know the weather forecast previously. You have to make sure that there's no data leakage, so you cannot use any information from the future. But it's very easy to create. It's kind of like a tabular data set that you can use with all these features. So you don't really have to do anything very specific to change it. You just have to make sure that you don't use any future information in your current model, because when you're in production, it doesn't have any future information, right?
No, you really have to make sure that you only use the historic ones.
Yeah.
Last question that I have written down here from Johan as well. When you are working with this temporal fusion transformer model, what was your first expectation? So what were the first results, and what can be improved?
Yeah. our expectation was that it would be better. The nice thing about this model is that we can now also use all our products during training. So where we had the gradient boosting regression tree, you saw that if you combine everything together, it actually doesn't play that nicely. So that we were actually under-predicting a lot. And now we can use the whole set to predict, which is a very big advantage. And now some of the disadvantages of using such a model is that it is computationally costly. So you need to know that you already have something that is working and then you iterate on that. I wouldn't advise to start with such a model. Always build it up. Some problems here is that it is quite new, so it is difficult to find a lot of documentation about it. It takes a lot of compute, so you need a GPU to train it. So it is some time investment. You have to wait a bit before you get the model. But in the end, like we did a few offline experiments and there it showed that the performance is actually much better and giving us much more, like all the articles and different horizons up front. So the advantages were better than the disadvantages in this case.
Do you think that Picnic will, because you just mentioned there is not a lot of information about this model yet, right? It's quite a new model. And is this the first application in the food industry of this model, or was it already? Do you already have some examples in there?
I'm not sure whether it's used a lot at supermarkets or at different companies. I do know that in the paper they tried it out on some retail data sets, so a deep data set of supermarkets where they showed that it worked well. But I haven't heard yet, so I'm very curious if there's someone that is also playing around with this. And I would love to share like information about it. Yeah. Yeah,
maybe even Picnic can write a paper themselves. This was the last question from the audience, but we do have some time left. You had some extra time because the introduction took a little bit shorter. I think that would be a nice opportunity for us to actually ask what other types of models or other applications of models, data science, you're doing at Picnic.
Yeah, sure. Yeah, it's very broad. So we own data in the whole supply chain, which means it's great for a data scientist. Some of the projects I've been working on is classification of customer feedback. So we get a lot of customer feedback in, positive or about issues. So for example, there's something broken, some products don't have good quality. And what we were noticing is that this grows and grows and we were having a backlog, but we couldn't scale our customer success as much. So this is where we added machine learning to classify what kind of tickets there were in or customer feedback so that we can actually route them to the correct person immediately and making it also much faster to process. So that's really on the customer side. We have machine learning for delivery forecasts, which plays very nicely with the article demand forecasting model. But we're also using machine learning to estimate how long it will take to deliver the groceries at your door. So for example, in our data, we see that if you live on the 4th floor, it's going to take a bit longer than when you live on the ground floor. Oh, yeah, wow. And if there is an elevator in the house, it might also be a bit faster than when you have to take the stairs. We all use this, all of these informations and models to create the fastest route to your house. And this is why we have these 20-minute delivery time windows, because we optimized it perfectly with this.
And how do you have that information if there is an elevator available?
Yeah. So we try now to ask our, we call them runners, so these are the people that deliver the groceries, if they can also write it down if they see this, or and we can also keep track of how long it takes to deliver. So in the end, we see an average, usually the amount of time doesn't really change over time, maybe in the traffic, but not at the moment that you're at the door. It's always going to be quite similar time to get the groceries at the door.
Wow, amazing. Yeah, it's really smart actually.
Yeah, to collect the data yourself.
Yeah.
And do you use traffic information as well? Because I can imagine that also has an impact on how long you need to drive, right?
Yeah, so we do use it a bit for the estimation of how much we drive. But what is very useful is that we have a very dense customer base, so they live close by, and because we only say that we don't give you a lot of slots. We say we are on Mondays between 4 and 6 you can order with us, or between 8 and 10. Which means we can group all the people that live close together, very close together, so that we can also reduce the amount that we are in traffic. So you don't have to go from one side of the city at 10 o'clock to the other side of the city at 11 o'clock. we cluster them and group them in such a way that we can reduce this traffic rate.
Nice, and it reduces CO2
yeah,
as well.
Definitely. Yeah, and we also have electric vehicles, which is also very good. Yeah.
All right. I don't know, Robin.
I have one more question.
Yeah.
I was just wondering, you talk about the different models and that you start with the baseline and then, over time you try to improve it.
Yeah.
I was just wondering, do you have a different rollout strategy per model, or how have you defined that?
So we don't have a very different rollout strategy. With everything, we try to analyze this a bit before we get it into production. Always talk with the business and have very close connections, especially when you just start rolling it out, because it could be that something you found offline is not working online, right? Mm-hmm. But in general, we try to do a similar rollout strategy. So we talk with the business, we experiment offline, and we make sure that there's this automated pipeline that we can put it in production every time.
Yeah, and it's automatically retrained.
Yeah.
I think we can talk for hours and hours about models, and I really like this, this conversation.
I love this, yeah.
But unfortunately, we do have to come to the break. Sharon, thank you so much for giving us insights in how data science is used to tackle waste in this case.
Thank you for having me.
In the food industry. And I think people had a good talk, both from technical side, right? What type of models do you use? How do you prepare your data, etc. But also from operations kind of view, like how does your data team work? How do operations get information back? So thanks a lot for that. We won't see you anymore.
No.
So
have fun today.
We definitely will. And thank you so much. Robey, we'll see you back after the next talk. So everyone who is watching, this was the first keynote speaker, Sharon Gieske from Picnic, talking about food waste in the food supermarket industry. Our next session will start at 2:15, so we'll now go quickly to the break, and we hope to see you back for another super interesting and mostly inspiring story of our second keynote speaker. See you then.
Hello, welcome back everyone. We have our final keynote speaker coming up for this series of webinars from Women in Data Science, organized by People. Before we start with an incredible speaker, I would like to remind you that it's possible to ask her questions. However, she won't be able to see the questions during her presentation, but later on, when she joins my co-host Roos Royakkers, Roos will be able to ask the questions you ask to Hezha, who's coming up as our speaker. So don't hesitate to ask the questions during the presentation, because otherwise you might forget what you wanted to ask. Besides that, Hezha has also prepared some interactive polls. So when she asks you a question, you can click on the right side of your screen where you see the word Slido, and then the poll will become active and you can submit your answer using Slido. Slido is also the platform you have to use if you want to ask Hezha a question. So don't click on the word Q&A, click on Slido and then on the word Q&A. Well, without any further ado, I would like to introduce Hezha. Hezha is joining us from the Tilburg University Zero Hunger Lab, which is an incredible organization that aims to reduce all hunger in the world, but Hezha will tell us more about that later. She is originally from Kurdistan, where she did her bachelor degrees. However, to do her master's and her pre-master, she came to Tilburg University, and now she's doing her PhD there. Well, Hezha, have a lot of fun and good luck with your talk.
Thank you. That's a long academic journey, as she mentioned. My name is Hezha. I'm from Tilburg University's Zero Hunger Lab. And today I'll be talking about how ways we use machine learning to tackle hunger. Before I start my presentation, I would like to ask everyone a question. And the question is, how many people in the world do you think go to bed hungry? I've given you some options just to avoid thinking of small numbers, because unfortunately the number is high. The options are 450 million, 690 million, and 970 million. Do we have some answers already?
Already, we have one answer just now, 690, it's two answers. Oh, I think it's already way higher than I would have expected. Like the lowest option is already higher than I would have guessed, which is, well, the audience was correct.
Yeah. Unfortunately, according to UN statistics, there are 690 people regularly that are going to bed hungry. And this could be due to poverty, but also due to armed conflict or natural disasters. Even worse than that is that every second a child dies of hunger somewhere in our world. In this presentation, I'll be introducing the Zero Hunger Lab ways. The Zero Hunger Lab use optimization and machine learning to tackle hunger. Among the projects that I will mention is the Child Growth Monitor, which is the research project that I personally work on, and we will go into more details about that project. So the Zero Hunger Lab is a team of researchers that work independently within the Tilburg University. We all have a few things in common, starting with creating value from data, and most importantly, ending hunger with data. How do we do that? With our research, we look for solutions. What do we need for this? We need very big data and computer power to come up with solutions and help make better decisions. Where do we use these decisions? We either use them for emergency relief. Like I said, some people are suffering from hunger due to armed conflict and natural disasters, and other causes that need immediate response. So we have to make sure that food is delivered to a lot of people very, very fast. And then another way we use these decisions are for sustainable development, to make sure that poor people have a sustainable way of securing food for a longer term. We do not do this alone. We do this with our partners. This screen summarizes the amazing collaborations that we have. Some of these partners, like Tilburg University's School of Economics and Management and Ministry of Foreign Affairs, bring us funding. Some others bring us more expertise in our research. And other partners like the WFP, Solidaridad, the Dutch food banks, the World Hunger Hezha are the partners that actually implement our findings in the fields. So those are the organizations that have direct impact on people's lives. We focus our research on 4 main areas when it comes to ending hunger. And in this presentation, I'll be covering 4 projects from each one of those focus areas. Those focus areas are emergency relief supply chain optimization. This is where we deliver food to people immediately. Well, not we, our partners, but through our research, we give advice, recommendations, and come up with solutions. We have Healthy Diet for Healthy People and Healthy Planet, where we do research about coming up with the best diet model that does not harm the environment and keeps our planet healthy. We do research on food system resilience. And finally, we do research on detecting malnutrition, which, like I said, is the project that I personally work on. The Zero Hunger Lab is not your typical man-led type of workplace. We have amazing women data scientists that are leading the projects, and all the 4 projects that I will be discussing today are led by women. So starting with the Dutch Food Bank, we have a long-lasting collaboration with the Dutch food banks. And the project that I will be talking about today, we have several projects, but the one that I'll be talking about today reflects the current reality of COVID that we're in. But to give you a bit more of background information about the Dutch food banks, there are 171 local food banks. They're independent local organizations. And each one of them at least have 1 location. So in total, we have 515 locations for these local food banks. And they have 10 depots that are demonstrated on the map. The way they work, is that unlike the supermarket that was mentioned before, they are not demand-driven, they're supply-driven. So the depots receive donations from national suppliers and regional suppliers. Then you have the local food banks that also receive donations from local suppliers. So as you can see, we have a lot of data to play with and to build a very interesting supply chain optimization model. Every year, the Dutch food banks help around 160,000 people in the Netherlands that need food. Unfortunately, this number is increasing due to the aftermath of COVID. So the research question we currently try to answer is that the Dutch food banks have received funding to respond to the increase in demand of food. And we're doing research on the optimal use of this donation to come up with a logistic structure that will best respond to this uncertainty and growing demand. The second project that I will be talking about is in Fonz. We have the World Food Programs as a partner, Capgemini, Johns Hopkins, and of course, the Zero Hunger Lab. What are we doing? We use data. The data that we're using is food, nutrition, local supply, cost of diet, and all of this, we feed it into a model. And we come up with a diet that's affordable, nutritious, and ecological. So a healthy diet that's affordable and does not harm the environment. This project does not only contribute to goal number 2, Zero Hunger, but it also contributes to climate action. Because as we know, the greenhouse gas emission is also one of the negative effects of climate change. In Fonz is actually a more advanced version of Cost of the Diet. Cost of the Diet is another system that is currently in use for 10 years. It was first proposed by Save the Children, and the WFP is using it to advise governments on diet. Cost of the Diet is taking into account nutrition and affordability. Within Fonz, we also take into account uncertainty and environmental impact. So with this model, we aim to have healthy people on a healthy planet. Our goal is to have nutritious, ecological, and affordable food. This is not only for poor people, but normal people and rich people also need a healthy diet. And this diet needs to be affordable for me, for example, and it also has to be ecological, so not harm the environment. The third project is designing pharma typologies for sustainable West African palm oil program. This program is with one of our amazing partners, Solidaridad. The research question we are trying to answer is how we can use data to help the farmers in West Africa be more productive and more sustainable. And for that, we collect data from over 40,000 farmers, and we cluster them, and then we give tailored recommendation to the required services and best management practices to adopt. This project is just starting, so we're hoping to see amazing results in the future. So now we're down to the project that I am personally working on. This project currently is my home life, not only because it's my job, but also because I have a 10-month-old son, which I care for his growth. And I make sure that I measure him adequately to make sure that he's growing well. We previously, the first speaker talked about food waste. And we're talking about the 690 people that actually need that food that is wasted. 200 million of those numbers are children. And we have 5.6 million preventable child deaths that are caused by malnutrition. When we say preventable child death, we mean these could be prevented if they're measured and we respond to them on time, then we can save these lives. And I would like to take a second to remind you all that these are not just numbers, these are human lives that we're talking about. That's why it means a lot to us at the Zero Hunger Lab. So the Child Growth Monitor is a mobile application using a smartphone that aims to take a picture of a child and diagnose malnutrition from an image data. It gives better height measurement because it removes the need for using heavy tools and wood that is not always accessible in rural areas. Speak outside Netherlands and Europe. Speak for the countries that, or the villages that are far away from medical centers. It gives better weight measurements because you don't have to carry the scale everywhere with you, worrying about it maintaining its accuracy. And then also digitized data, because are we measuring kids and also documenting? Do we put them on the right graph curve to follow their growth? These are all contribution of the Child Growth Monitor. The Child Growth Monitor is a project of our partner, the World Hunger Hilfe. The first pilot project was implemented in India, and they have spent the last 3 years collecting and piloting, basically testing the app. It is still in baby steps phases, but we hope that in the near future we can come up with a result, and that's why they have partnered with us, the Zero Hunger Lab. We have a great collaboration that started in 2019. I've already done my master thesis on this project. The main objective of this collaboration is basically to make this happen, minimize the time and effort in recording and photographing, maximizing the reliability of the measurement, and also the explainability and transparency of this algorithm that we co-work on. The impact would be timely intervention with children that suffer from malnutrition and hopefully save their lives. This is a highly scalable solution that leverages cloud-based AI technology on mobile devices. So what are the research questions we have to answer in this research project? As you may know, a PhD trajectory, you never know what happens. You have some questions this year, and next year you come up with amazing findings that change your route. But for now, we're starting with simple questions. Is it really possible? Can we predict body shape parameters from 2D images? And does that depend on viewpoint? So if you take a front picture of me, would that give a good result? Or should you take a top photo or a side photo? So these are questions that we try to answer. What deep learning model would give the most accurate prediction? And what type of data should you use for training the neural networks? Should you stick with an image? Should you use video? Should you convert the images to point clouds and depth maps? Are all experiments that we have to do within the next few years. So the first approach that we used, so we're talking about children and children data. And there are a lot of GDPR compliances when it comes to sensitive data, because these children have to be partially dressed. Their face might be visible in the picture, so all of this has to be taken care of. So data has to be anonymized. We have to receive consent from their parents, because when you train a model, you need data to train it and for the model to learn from it. And in our case, the data is pictures of children. And if you want to measure their height and weight and upper middle arm circumference, they have to be lightly dressed. And that is, for countries, if you're talking about a girl lightly dressed, is kind of sensitive. So to gather that data is a lot of work, and we do not want to cause harm while trying to do something good. So we must make sure that everyone's right is protected, that we have consent, and everyone is participating in this research out of their will. As we wait on that to be ready, we did not want to waste time, and we immediately started working with virtual data. So we have virtual data, humans that are rendered in 3D shapes. We used sophisticated softwares to generate 2D images of these 3D shapes. And then we applied principal component analysis to extract their measurement in principal component values. and we fed them into a convolutional neural network to see how it will perform, and then we have very promising results. The principal component analysis does not only give us the labels to train on, but it also shows us the variety of body shapes that we have to train on, because you have people of different sizes and shapes. So some children are tall, some are shorter. So the principal component analysis shows the variation of body shapes that we have in our data set, which is a positive point because it reflects the reality of humans. For our training, we used two widely used CNN architectures. As you may know, science is built on the shoulders of a giant. So we did not have to build a model from scratch. We used pre-trained models from Keras application model. We use ResNet because it allows us to train very deep convolutional networks, and Inception v3 because it allows to use to train convolutional network of different sizes in the same convolutional level. I'll not go into the details about these models. You can read the papers, but they have very high capability in extracting features because they were trained on ImageNet, and then we retrained the models on our data set that we have. So the results compared to papers that are using ResNet to extract body height and weight from facial images, our model outperformed them significantly. Previous models have around 70 to 78 millimeter errors, but we have 9 to 10 millimeter error rate. Same goes for the waist circumference. Previous literature have around 70 millimeter error rate, but we have 60. Now this is promising in terms of numbers, but when we talk about these numbers for children, it does make a huge difference in detecting whether they are malnourished or not. While these numbers will not be used directly to make the diagnosis, the World Hunger Health Fund is in the long process of getting a certification for the Child Growth Monitor to be certified as a medical app. Those are details that we will not go into, but a model must have a much lower error rate to be reliable to be used on children. This model is not validated on real human data yet, so we don't know how it will perform, but that is something to work on in the near future. So what did we find? How does viewpoint affect this? Now, for the height, the viewpoint is not affected. And you have around the same accuracy level if you take the photo from the front or from the back or the side. But when it comes to anything that has an elliptical shape, so the waistline, the middle upper arm, or the head, every view is limited to what it sees. So if you're looking at my head from here, you don't know how much further it goes from the back. If you look at the belly, you don't know how wide it is. So it is difficult, and we, in our preliminary finding, we think having a 360 view or a video might be better for estimating a circumference of head or middle upper arm or waistline. So to conclude what we talked about in this presentation is we introduced the amazing work that the Zero Hunger Lab is doing. We introduced some of our partners and the projects that we have that are led by women. And we hope that you visit our website and follow up with the amazing work that we do.
Okay. Well, thank you, Hezha.
Thank you.
I think it's really inspiring how you turned your knowledge of AI into a useful way to address hunger and make people more aware of the problem that we have. Because it's not something I would think about if I think, what do I want to do with my knowledge of machine learning? I don't think, oh, let's end world hunger. But you showed us it's possible, so thank you for that.
Thank you.
I would like to invite you to join the discussion table.
Thank you.
Welcome back, everyone, to the discussion table. So this will be the very last time for me to do this, and I'm really excited. As as you might know, this is our last webinar of the Women in Data Science series this year. Maybe we'll see you back next year, but before that, make sure to watch our Women in Data Science webinars back via our website, wids.nl. You can see what all other speakers have been talking about. It's really inspiring. We talked about data science at really big corporate companies, how they work with that, how to make data science your ikigai, data science in health. It's all really interesting, so make sure to check it out. As you might know, I have my laptop standing beside me, and if you have any questions for Hezha, don't hesitate to ask them. You can do that in the Hopin platform, so you can go to the right-hand side. There you have an option called Slido. You have the Q&A, and there you can ask your questions. And I already see Johan, you are very active. Thank you for that. You are asking the first question, but I'll come back to that at the end of the discussion panel. So after a small technical problem on this side, but you haven't seen that, so that's really good. We go to the discussion. Hezha, thank you for joining.
Thank you for having me.
How are you feeling?
I'm feeling great about this, that we get to share the amazing work that we do, and hopefully we inspire people out there to use their machine learning language, knowledge for something impactful.
Yeah, I'm also really happy that you're here. And I have known about the Zero Hunger Lab since 2 years now. I think an old high school student, a colleague, how do you say that, of mine, he is also working or was working at the Zero Hunger Lab, and that was the first time I saw it, and I think it's really inspiring what you guys do.
Thank you.
First and foremost, I'm not the only one who thinks that, because I know that recently you have won the Franz Edelman Award.
Yeah. The Franz Edelman Award is the world's most prestigious award in research analytics. We won the award together with WFP. Our colleagues, Koen Peters and Professor Hein, have been working on the Optimus model for a very long time now. And we were competing with Alibaba and Amazon for that award, but apparently doing research for social good is of value, and we're very happy that we're receiving this recognition at Zero Hunger Lab.
Yeah, it's really amazing what you guys have done there. And yeah, just for the people that don't know, so the Franz Edelman Award is one of the most prestigious awards for analytics. And it is an award that you get when you have a lot of impact with the thing that you're making. And it's a really big innovation in this type of area. So it's really impressive that the Zero Hunger Lab managed to win this award, and I think it's not even the first time they won it, right?
No, Professor Hein is winning this award for the second time. I think he's the only person in the history
it's really amazing
to win this award twice. So it is amazing. It's also very inspiring for us to work with them. Yeah. So it gives us, we have our daily doses of motivation from not only Hein, but everyone on the team. We have a huge team of professors, assistant professors, PhD students, and a lot of master students that are doing their research, their thesis with us. I was one of them last year, and I'm doing my PhD this year. So there's room to grow. There's room to turn inspiration into real impact.
So the Zero Hunger Lab, it's a group of people.
Yeah.
So
it's like a research center.
How many are there?
So we are over 20 people, including the master student, the PhDs, and the professors that support us. Yeah.
And you managed, so the Zero Hunger Lab managed to create this big community actually of all types of partners, the food bank, the World Food Program, everyone around them, with the sole purpose to fight malnutrition or fight the hunger in the world. One of the Sustainability Development Goals for 2030.
Yeah, and we only have 9 years left, so we have a lot of work to do.
Yeah. I was just wondering, how have you defined your success criteria, and how are you going to measure it?
So we're not in this alone. We have our partners, but also the SDGs is a call for action for everyone, from individuals to organizations and governments. I think the only way to measure it is just less people going to bed hungry. Yeah.
And that is measured by the United Nations?
Yes, every goal is accompanied by indicators that indicates the success rate of the collective work that organizations and governments do to achieve those goals. But there's the Social Progress Index website where you can see a short overview of how each country is doing in select areas, so healthcare, nutrition, infrastructure, and so on.
Oh, it's quite nice that you have, you know which parameters you can contribute to and how it's measured. So that's it also gives you quite clear indication of how you contribute to that. Yeah,
for all 4 research areas that we work on, and for each project that we work on, we make sure that we collect data on the geographical area that we work on, and we collect as much data as possible about the problem that we want to solve. But we're doing research, and research takes time. So yeah, hopefully we all see results together soon.
Let's go to your presentation, because you've told us a lot of information. So first of all, you mentioned 4 focus areas of the Zero Hunger Lab, and you showed examples of things that you do there. So can you say a little bit about how many projects do you actually do with the Zero Hunger Lab? Because you're only with 20 people.
Yeah.
How many are currently running?
So yeah, there are currently 6-7 projects that are running, and other projects that are in planning phase. So because we're doing research, sometimes you plan something, you come to a point, and then you go 3 steps back and come 4 steps forward. So we're always in this phase, but we currently have around 6 to 7 projects that are running, and we have different people working on each project.
At what point is a project done for you? So does that mean that you have built something that is being implemented, or at what point do you decide, okay, this project is now over?
So with each collaboration, we have a time frame. For example, for my collaboration with World Hunger Hilfe, we have planned 4 years. That's a PhD trajectory. And then we have milestones within those 4 years. Because to do a PhD, you need to publish papers. So each paper is a milestone for us.
I can imagine that the way of working is also different than, for example, in commercial perspective, right?
Yeah.
I know I have my way of working. I work in certain phases, and I do certain stuff after one another, and I take into account businesses. But yeah, for you it might be different, and I can imagine that Robey would like to know a little bit about that.
Yeah, it also differs per project. The Dutch Food Banks project that I talked about, my colleague Maika would have to give results this year to the Dutch Food Banks so they can implement it directly. So it depends on the project, the type of collaboration we have with a partner, and the flow of the research, and if we actually find anything in our research.
Yeah, because I think it takes a longer period of time because you're doing research as well as building the model. Yeah. Then it takes a bit more time that you show the results to the partners. How does that work, and how do you react upon that?
First of all, to train a model, we need data. So sometimes the data comes in very fast, like in the Enhance project, and sometimes the data takes a lot of time, like in the Child Growth Monitor project. And once we're done with the experiments, we sit together with our partners and discuss the findings and share our lessons learned in the hope that it would contribute to their project in the ground. And we have seen results, like with the WFP, it has increased the number of beneficiaries with the same amount of money. They are able to target more people and give food to more people now. So it takes time, but it has an impact, and a sustainable impact. That's what we work on.
And since you're a research lab, do you have additional steps compared to maybe a commercial environment where I work in, and you from a consultant perspective?
Oh,
compared to budget, because of course you get a budget to work on a project. Are there additional steps that you have to take into account, or? So
those are things that managements actually do that. So I do not know anything about budgeting.
Oh, that's nice. That's great. So you can focus on the research and
yes, and especially the Zero
problem.
Hunger Lab team, we make sure that the researchers are working in peace and are dedicating their entire focus and attention to the research to make sure that they're coming up with great results. So I personally don't have to worry about how the budgeting works. But of course, we struggle for budgeting, especially in times of COVID, where allocations of FUD might not be as easy to access as before. We've been funded by the Ministry of Foreign Affairs, Tilburg University's TISM. So, and we hope to get more funding, of course. We have people that are continuously writing proposals and reaching out to donors. And with the great work that we do, we are confident that we're attracting good donors soon.
Yeah, because you showed this slide with all the partners. There were a lot. So you have a whole ecosystem around you with partners that where you work with on different topics. That was just
but like I mentioned, not all the partners bring funding to the project. Some of them bring data, some of them bring research expertise that we don't have. So it's everyone is giving. It's not always funding, but it's some sort of resource that we need to do research.
It also depends how close you collaborate with them.
Yeah. We work independently at the end of the day. We do our research unbiased and independently from all our partners. We use their data, we use the resources, so we share expertise. But of course, for research to be valid, it has to be unbiased and independent.
Yeah. Let's move to your project, because as you said, you don't know anything about funding. It's also not too much important to you. Let's talk about child malnutrition. You are working on a child growth monitor. I have a lot of questions about that. I see a lot of questions coming in here as well. Let's start with first things first. You need data for your models, right? How do you get that? You mentioned you were talking about 2D data or maybe a video. What's the current situation? What did you find?
So the current situation is that we're working with virtual humans. So the only publicly available data set with labeled human shapes is the CESAR data set. And that is only human bodies of adults, so 18 years and older until 65, I think. It doesn't give us too much room to work with, but we have taken out the best that we can do with it. So we've turned these 3D shapes, we've used the mesh of it, so we have not bought the actual data set. We used the meshes of the CESAR data set from other papers, and we applied principal component analysis, and we have a great data set to work with and experiment with until we have access to children data.
Just a quick intervention, principal component analysis. I know I've had that when I was in a university, but can you quickly explain what that is exactly?
Oh, well, that would be a lot of detail. I recommend
just like the really basic stuff?
Yeah, it is also a machine learning algorithm that we apply to the data set to extract the labels, because these meshes came without labels. By labels, I mean their height, their waistline, their weight. Of course, virtual humans do not have weight. And we also extracted the extreme values, as you saw in the photo, so the thinnest and the widest person in the data set. And that was very helpful for us to see the variety of shapes that we have. And we used it for training our model.
Yeah, you mentioned virtual humans don't have weight. Do you need weight?
Yes, of course.
How do you work with that?
So according to the World Health Organization standards, there's a specific height to age and weight to age that a child must have for us to be sure that the child is growing well. And that's why we need weight. In adults, I'm not a medical expert, but from the research, I have some information. So for an adult, you calculate BMI to decide if a person's weight is within a healthy range. But for children under 5, we use height to age and weight to age to determine that they're growing healthy. In the current phase of our research, we are working on making the best prediction on height. We take one step at a time. We're very ambitious with the Child Growth Monitor project, and the only way for us to achieve those goals is by taking it slow and taking baby steps. At this phase, we're focusing on the height prediction, but we are also in the process of collecting data in Africa and India. Clean, structured, labeled data, of course, is what we need to train our models. So the current situation is that we're using the virtual data to make the best prediction on height, and we're also in the process of collecting data legally with consent from parents and make sure that the data is structured and is clean, ready to train a model on.
I was wondering, how do you label the data? Is that something that you do within your team, or? No,
so we do not have the medical expertise to do that. Our partner, the World Hunger Hilfe, is working with local organizations in India to get the labels. They train their field team on measuring these children. They record it, they attach it with the photos, make sure they get consent from the parents, and then they make it ready for training. As you can imagine, this is a lot of work, and is very time consuming.
And also privacy sensitive, I guess.
Yes, exactly. So the data storage and sharing data, so far we haven't been able to extract those photos from their pipeline so we can work on them, because we do not want to, they cannot share it with us yet. We do not want to do anything that is not considered legal or lawful processing, is the term that is used in GDPR. But within the next few months, we will collaborate with them on data collection so we can have lawful access to the data and work with it to train our models.
You mentioned baby steps. First step is to actually measure the height based on a photo or based on an image or video. And later you will probably go to waist size or something and weight measuring. You listed some results in the presentation before, and I saw that there were mean average errors of less than a centimeter. Is that really the accuracy that you need? Because less than a centimeter, for me that sounds, I don't know if I'm 183 or 184. For me it's also not very important, but is that, what accuracy is important for you?
So because we're working on this algorithm to give it to the World Hunger Hilfe, or we're helping them with the development of the algorithm, they are the ones to decide which accuracy is what is needed. And keep in mind that this will go into the end-to-end production of a mobile app that needs to be certified as a medical app. So as researchers, we will do our best to come up with the best prediction that we can come up with, and we let our partners decide if that's good enough.
Yeah, and do you already have any ideas on what's going to happen for the other two steps that you're taking? So the weight, the weight and the waist range?
Also the middle upper arm circumference. Yeah, the models are great. They have high capability of extracting features from images, and we will see what happens. I cannot give you results on answers about future, but the first research that we did, and that's the most important thing, is that it's possible. When something is possible, there's a lot of room to improve. And
well, you are a research institute, so I hope you figure out how it works.
We're doing our best, of course.
And how did you include explainability and transparency in your model?
So that's something that we yet need to work on, because that is something to come after the model is used on real human data. But explainability and transparency, of course, is something that is very important, especially in this research, because we're making decisions about a child's health. So we have to be able to explain how it works and also translate the results to human language.
Yeah.
Yeah.
All right, I have not too much time and a lot of questions from the public, so I would like to propose to go to those. And yeah, well, if anything comes up, I'll be
it's okay.
Just say it, right? There's so many questions that I don't have the power to structure them, so I'll just go from top to bottom and let's see how it goes. First question. You are going to take an image of a child as an input, and the output is going to be the body shape or malnutrition level. Is this app for social workers, or for who is the app designed?
So let us separate the algorithm, the model that I'm working on, and the actual app that is owned by the Child Growth Monitor and the World Hunger Health. The model will be given an image, and the output would be the measurements that we're receiving.
Yeah.
The end-to-end engineering of this will include comparing these results, these measurements, with gold standards of a healthy height and weight range, and then it will decide if this child is diagnosed with malnutrition or not. From what I know and the information that I've received from our partner is that in the current phase, it is only planned to be used by medical staff. So they just take the phone with them, go to the field and measure children. But we hope and aim that in the future, this can be an app that I can use at home to measure my child and ensure that he's growing healthy.
Yeah, perfect answer. The ZML, I'm not sure what ZML is.
ZHL. ZHL is stands for Zero Hunger Life.
Yeah. ZM are also looking at the optimization of food chain. I have to do this better. I'll do it again. Is the ZML also looking at the optimization of the food chain for the Netherlands, but maybe also somewhere else?
So when we do supply chain optimization models, and we did that for WFP that are going to use this in their projects all over the world. And it's not the entire food chain that or the current research focuses on, at least for the Optimus. It is where to buy food, which road to use to send the food to distribution centers. So it's not only within Netherlands, but it depends on where our partner works. WFP works all over the world. Dutch Food Banks works only in the Netherlands. So I would say that we work globally, and of course globally, not within only the Netherlands. Yeah.
All right.
Our goal is very big, is to tackle hunger around the world. That's our mission.
It's really ambitious,
yeah.
But I hope you manage to do that.
Yeah.
I have 5 more questions left. I see it's 3 o'clock right now, but I think we can. We have 5 more minutes to capture them. Also because we originally scheduled for a networking room for the last half an hour. So if it's okay with you, I would like to continue, and I hope for the people at home that they can stay and watch the last 5 minutes. Next question is, AI struggles with different skin colors sometimes, especially when looking at pictures or videos of people. How do you address this type of problem?
Yeah, that's actually one of the questions that I asked during when I first joined the project, is that how is the model going to react to skin color? Which is why in the current data set that we have rendered our humans, our virtual humans, in different colors to see how it will perform. So we will have to wait and see. Yeah.
But you are addressing the issue, so I'm really happy about that.
Yes.
It's sometimes difficult to actually do that.
No. We have thought of that. That was one of the first questions that I had myself. And eventually, when we collect the data, we will make sure that we collect data of diverse data of people of different skin. And also, a child that is considered tall or short in a country is not the same as like in Germany or in the Netherlands compared to Kurdistan, where I am from. So it has to be country specific. But like I said, the standards come from the WHO. They come from the experts, and we are also not associated with that. But when it comes to the model, our job is to make sure that it's trained on a diverse data set, and we are trying our best to do that.
Speaking of diverse data set, the next question is about what happens if you use data from people with eating disorder?
Yeah, we will have to wait and see what happens. Yeah, yeah, but it's very important to mention that we're talking about malnutrition. We are talking about people that are not receiving enough food. But this will also detect people that are eating too much food. So this is not only relevant for poor countries, but also for developed countries, especially countries that are suffering from obesity, mainly in children. So it should be able to detect all types of malnutrition, whether it's underweight or overweight. And malnutrition does not always affect the weight. It affects the growth, and that's the problem. It affects the growth of the child.
Yeah. A really small question, quick question. How large are the teams that work on one project? Because you mentioned 20 people, 6 to 7 projects, I believe.
I can answer for the Child Growth Monitor. From the Zero Hunger Lab, we are 4 people, a full professor, 2 assistant professors, and myself. They're working on the project. I would like to mention, for the people who are in the world of AI and machine learning and deep learning, they should know Eric Postma as the lead professor on this project, who is, I consider him a god in deep learning.
Eric Postma?
Yeah.
Okay,
yeah.
Make sure to look him up.
Yeah.
Last 2 questions, and then we really stop everything. A really good one, actually, also including you, Robey. Is the Rabobank a partner of the Zero Hunger Lab? Because the Rabobank is also in food and agri.
It's indeed, but I don't saw us on the list, so we're not the partner yet. But I have lots of questions still, so we will definitely have a conversation after the discussion panel.
Yeah.
Who knows, maybe in the future.
Yeah, this might be a start of a new collaboration.
Oh, and last one. Last year, a new Dutch book came out, Nederlands Voedselparadijs, from Barbara Baarsma, about opportunities for shorter food change. Do you have any comments on that? Are you aware of the book?
No. Maybe, yeah.
Yeah, she explains that you want to shorten the food chain. So sometimes we buy products from New Zealand, for example, so kiwis or something. So how can you buy your products locally?
Oh, that's what we do with Optimus. That's basically what our supply chain optimization models do. Instead of buying lentils and beans from Brazil to deliver it to Syria, why not buy it in a neighboring country? Yeah. So that's exactly what our supply chain optimization models do.
Can people find more information about Optimus?
Of course, yeah, there are papers. The Edelman paper, they can read.
Make sure to check out the paper.
Yeah, there are videos on YouTube about it. They can go to our website, and there are papers published. So yeah, there are a lot of information about Optimus online. Just go to our website, and it will give you links to everywhere you should go to.
Perfect. I think I'd like to end with that. It was a really a big ton of questions. Thank you for having the time to be here, Hezha.
Thank you.
And for telling about your research as well, because this is something completely new to me, and I'm really happy to see that techniques like image recognition, but also deep learning networks, neural networks, everything can be used for such an impactful and ambitious project. And I really hope you succeed in the coming years in your further research.
Yeah.
Robey, for you as well, thank you for being here and asking a lot of insightful and interesting questions. I think people got more background about our keynote speakers because of your questions. And,
thank you, I really enjoyed it and it's very insightful.
And who knows, maybe we'll see you back next year.
Hopefully.
We'll see. For everyone watching at home, thank you for being here. Thank you for asking a lot of information and a lot of questions to our keynote speakers. I think they really enjoyed it, and it's also really amazing to see how you are participating in this webinar. I've mentioned it before, but we have 2 other webinars that are already online on our website that you can watch back. 4, well, actually 5 amazing keynote speakers and a lot of fun panel discussions as well. So make sure to check it out, wids.nl. And by that, I think we're here to close the last webinar. So thank you a lot for watching this last webinar from Eindhoven, organized by People for Women in Data Science. And hopefully we might see you next year. Have a nice day.